Hi friends, welcome back to Edupedia world. Last lecture we discussed about Lorentz force. We saw how a current carrying wire when placed in a magnetic field experiences force. Today we will use that concept to build what is known as a DC motor. We will understand what a DC motor does. We will see what is the construction and how exactly does a DC motor work. And finally we will conclude the lecture by discussing the ways to control the speed of rotation of a DC motor, increase or decrease the speed of a DC motor. So let's get into the application of Lorentz force, that is DC motor. Today's lecture we will discuss about DC motors. DC motor is a practical application where the concept of Lorentz force is put to use. Now to begin with, let me say you what a DC motor is and what does it do. A DC motor is a device which converts electrical energy into mechanical energy. So basically by inputting electrical energy you get mechanical energy out. In DC motor normally what happens, the electrical energy is converted into the rotation of an axis, and that is used to rotate, let's say, the fan or any other device which requires circular motion. Okay, so that's how electrical energy is converted to mechanical energy and put to use. Now if you see the simple construction of a DC motor, it is like this. Let's see this left construction. Here you have a source of energy, the battery, which will provide the current, and then this B1 and B2 are known as brushes. They are copper brushes which provides electrical contact. Okay, this are the two S1 and S2 are known as commutators, and they are also known as split rings because they are split in two parts. Okay, and this brush is attached to the wiring system here, but the split ring is free to rotate. So this rotates with this whole system. Now what is this system? This system is a wiring, and inside it over here is a soft iron core. Why the soft iron core? Basically this helps the magnetic field to play its role over here, and this binding is armature coil which basically allows the current to flow around the soft iron core. We have a shoe magnet here such that this is the north pole and this is the south pole, and the magnetic field is from north to south in this direction, and it is in such a way that it is in this plane, right? Now the current starts flowing from here. It goes in this direction. This B1 in contact with S1 lets the current pass through here, and that transmits in this wire over here. Here in this wire it goes down through B1 and S1. It passes through here and it completes the circuit. So this is the basic construction of the DC motor. Now to begin with, the coil here is in the same plane. The plane of the coil is in the same plane as the magnetic field. Okay, so let's say at this moment I started the system, I switched on the system. What will happen is that the current will start flowing, and since this split ring is in contact with B1, the circuit is complete and the current is flowing in this direction. Over here what is happening, the AB section, let's say in the AB section we have the magnetic field pointing out in this direction and the current is flowing in this direction. Okay, so if you apply the Fleming's left hand rule, you will find that the Lorentz force is acting downwards here. So here the force is acting downward, and Similarly, if I apply the Fleming's left hand rule in this branch, then what will be happening over here is that the current is flowing in this direction, the magnetic field is in this direction, therefore the force will be applied in the upward direction. So this is at CD location, this is at AB location, and as a result this is applying a force in the upward direction. This section, the BC segment and the AD segment, is parallel to the magnetic field, therefore no forces are exerted on these two sections. Therefore we see that a force over here is in downward direction and a force over here is in upward direction. These two will act as a torque and will start revolving the system. So this whole core will rotate about this central axis. Okay, now once it starts rotating and once it reaches close to 90 degree, what will happen is that this segment and this segment, since this is attached with the coil, this segment and this segment will become something like this and this, isn't it? And they will no longer be in contact with the brushes. Therefore the current will stop to flow for that moment, but due to inertia of rotation, the whole coil system will keep rotating about the axis, and once it has rotated through 180 degree, we will reach from this configuration to this configuration. What is the difference now? This whole plane has just rotated through 180 degrees, so now this has become the D location has come here, before D was here, A has come here, C and B also have exchanged their locations. But as soon as this happens, my split ring, this should be S2, since this has come from here till here, S2, and this is S1. Now S2 gets in contact with B1 and S1 gets in contact with B2, and the circuit is again complete. Again the current starts flowing, and since there is no change in the polarity of the battery, the current will start flowing in the same direction. That is, current is flowing in this direction, over here in this direction, over here in this direction, thereby completing the circuit. Since the direction of current has not changed and the direction of the magnetic field remains the same, again the situation arises similar to here, and a force is acting downwards here and acting upwards here, creating a torque in the same direction in which the coil is already rotating, thereby it further rotates the coil, and this leads to a continuous rotation of the coil system. And if we attach some motor over here, something over here to the axis, then that system will start to rotate along with the coil, thereby the DC motor will come into play. Okay, so now we have seen how the Lorentz force is put to use to create the torque, which thereby produces rotational motion. Okay, now how do we increase the rotation? In order to increase the speed of rotation, what we can do is, one is that we can increase the strength of current, the current which is flowing here, current increase. Second thing what we can do is we can increase the magnetic field, B can be increased. We use a different shoe magnet which has higher magnetic field. How do we get to this? We get to this because we know that the Lorentz force B is equal to F is equal to BIL, where B is the magnetic field. So if we increase the magnetic field, force increases, thereby torque increases, thereby the speed of rotation increases. If we increase the current, similar phenomena occurs. And thirdly, if we increase the surface area, thereby increasing the length, okay, that will result in a increase overall increase in the rotation. And finally, we can, in this loop, the coil, we can provide multiple loops. So by increasing the number of loops, we can increase the Lorentz force, effective Lorentz force, thereby increasing the speed of rotation. So the third is area of the loop, and fourth is number of turns in coil. These are the methods by which we can control and increase the speed of rotation of a DC motor. Okay. Now, one important thing is, what is the purpose of this S1 and S2? Why is it split? It is split so that the direction of current is maintained in the same direction. Okay, and even though it is split, when the current is no longer maintained, the inertia will take care of the further rotation till it attains the position where it is connected with the brush in the opposite direction. Okay, so we see here how by careful implementation we can create a DC motor by a very simple setting of magnetic field and current. Thereby we can say that this actually fulfills the criteria where electrical energy, that is the current flow, is being converted into mechanical energy, that is rotation. Okay, so I hope this lecture gave you insight into DC motor, which is a practical application of Lorentz force, and you should be able to understand the parts of a DC motor and how exactly the DC motor works. Next class we will start discussing about electromagnetic induction. So till the next class, have a great day. Goodbye.